Hello everyone. This is the second webinar in the webinar series on aerospace intelligence, strategy, and security. In this second webinar, we'll be looking at aerospace strategy using DeepSeek. Specifically, we'll also be looking at Grok and Copilot as intelligence technologies. With applications to game theory, how to get these generative AI systems to produce a game based on an analysis that they may produce on the current situation. This is the second webinar in this webinar series. I'll place in the video description below the link to the webinar to the whole series. My name is Carlos Pedro Gonçalves, so I'm an associate professor at Lusophone University in the School of Economic Sciences and Organizations in the Department of Management on Civil Aviation and Airports. I'm researching on complexity sciences, chaos theory, risk science, quantum technologies, artificial intelligence, strategic studies, studies in intelligence and security. I've also researched into fintech and financial risk. I'm also a software developer in the fields of complexity sciences, chaos theory, artificial intelligence, data science, and quantum technologies, as well as intelligence technologies. So regarding this webinar series, it's within the research fields of chaos theory, complexity sciences, as well as studies in intelligence and security and AI, artificial intelligence. So basically, the disciplinary context of the webinar series is intelligence and security, first and foremost, intelligence technologies, and we'll also be looking at, in the third part of the webinar, at chaos theory and complexity sciences and the use of machine learning in the empirical methods of chaos theory and complexity sciences, specifically in the application context of this webinar series, which is aerospace security. And in the case of the third part of the webinar, we'll be looking at solar science as well, still in the context of aerospace security. In terms of summary of the webinar, we already covered the first part of the webinar, in the previous video. Um, which you can watch going to the link for the if you click on the link for the webinar series. The first part deals with intelligence in general, so the concept of intelligence in the context of intelligence and security studies. We also looked at intelligence technologies, how the fourth industrial revolution is impacting intelligence, and the main conceptual basis regarding intelligence and its recent transformation. And this was done independently of the application context. So in the more general context, where we covered both business intelligence as well as intelligence in the context of strategy and security, strategy, defense, and security. This second part of the webinar series is focused on generative honest AI as used as in the context of intelligence. So we'll be looking at generative AI systems employed as intelligence technologies, and we'll be looking at DeepSeek for strategy building, specifically the case of the European Space Agency, where we'll ask DeepSeek to propose a strategy for the European Space Agency, taking into account the current geopolitical context that results from Trump's election as the new president for the United States, and the consequences of Trump's recent behavior and foreign policy, its impact, geopolitical impact, and what does this mean for the European Space Agency. Besides this application of DeepSeek, we'll be looking at also at Grok and the Copilot. And in this case, Grok and the Copilot will be used for, as an example, also in the case of aerospace, the context of aerospace, and the current geopolitical environment produced by the Trump administration, and the new direction in which that administration is taking the US. We'll be looking also at game theory, so how these tools can be employed in the context of applied game theory as intelligence technologies regarding strategic analysis, scenario analysis, and so on. The third part of the webinar will be looking at another type of application, in this case, not generative AI, but topological data analysis using combined with combining topological machine learning, adaptive AI systems. So this is smart topological data analysis in the context of empirical methods from chaos theory. We'll be looking at also at fractal analysis and other methods from nonlinear time series analysis applied specifically to sunspot dynamics and the decomposition of sunspot dynamics, which will allow us not only to predict sunspot dynamics, but also to find uncover different chaotic attractors, actually two chaotic attractors present in that dynamics, and will decompose the whole system, the whole components of that sunspot dynamics down to white noise. So we'll see the two chaotic components plus an ARIMA component, and then a white noise component. So we're dealing with stochastic chaos in what regards sunspot dynamics. So we'll be looking at the main features of sunspot dynamics, why it is relevant for aerospace security, that monitoring of solar activity and the prediction of sunspot dynamics, as well as the understanding and modeling of sunspot dynamics. We'll be looking at all that in the context of intelligence technologies. In this case, the application of machine learning and methods from chaos theory. So this is the third part of the webinar. Looking now at the second part of the webinar, we recovered, it's important to recover the intelligence cycle that we addressed in the first webinar. So in the first part of this webinar series. So in the first part, we looked at the intelligence cycle, starting in the definition of whenever we have a decision problem that needs the production of knowledge. We need to produce the knowledge necessary for a strategic foresight to support decision making. This means that we need to look at what the problem, understand that problem, what we have, what we know, what we don't know about that problem, but need to know, defining then the specific intelligence requirements that are needed to solve that problem. So we need to produce a plan for data collection and types of analysis that we need uh, to develop data processing and analysis that we need to employ on that data in order to produce the knowledge that we need to to solve that problem. And then we produce an intelligence report, which is disseminated and is used in order to make an informed decision. So the main issue that you can review the first webinar, um, the first part of this webinar series in the webinar series link, the YouTube playlist for the webinar series, and we. When we look at this intelligence cycle, the intelligence cycle is being strongly transformed by AI systems, by the new technologies that come out of the fourth industrial revolution, including the development of the Internet of Things, of the artificial intelligence of things, and now of generative AI. The main issue of generative AI, which is interesting, in particular, generative AI systems that can collect information from the web, is that you can ask it to produce a strategy recommendation and they will perform the whole cycle They will go through the whole cycle. They collect the data, process that data, and can analyze that data and produce a synthesis. And that synthesis can be a recommendation for a strategic recommendation. Fundamenting that recommendation, we'll be seeing DeepSeek doing that. We can also they can also synthesize a strategic situation in terms of strategic interaction pattern into a game theory matrix, for instance, and produce an analysis including of that of including calculating Nash equilibria and produce a whole analysis in turn around that strategic situation. And we will also be looking at that point here. So this is possible due to the new large language models that are freely available online and also in paid format. And it's particularly relevant for both business intelligence as well as in the intelligence and security sector, defense and security sector, to look at this because this is a tool. It does not replace um, the human analyst, but it can enhance that analyst's analysis by providing a new perspective. It's like adding to your team members an artificially intelligent team member that is able to collect the to given a problem, given a decisional problem, given a strategic analysis problem, that team member can collect, process, and produce cognitive synthesis, algorithmically led, of course, and that synthesis is communicated to you in natural speech. It can also produce mathematical analysis using game theory, for instance, and collecting and analyzing the geopolitical context and producing a game matrix that you can look at, that you can play with, that you can change even. You can ask it to change that game matrix to include more strategies. Yeah, and if this scenario changes in this way or that way, and it can produce that and it produces that relatively fast. So this is the main issue. So when we look at these AI systems, these large language models, it's important to see the difference between the concept of narrow AI versus general AI. So narrow AI or artificial narrow intelligence, ANI, is an AI system that is programmed for one specific task. An artificial general intelligence system is an AI system that is able to perform multiple tasks. So, under this strict definition, the large language models fit the concept of a basic form of artificial general intelligence, that is AGI. Now, there is a certain confusion, sometimes a conceptual confusion, in regards to AGI. So, the definition, strictly, the definition does not refer to, if you consider this definition of AGI as a system that is able to perform multiple tasks, and even to adapt to new tasks, given a basic programming where it's able to learn, to adapt, uh, given an algorithmic basis for learning. Here you have algorithms for learning, and if that system is able to perform a wide range of tasks, it fits a concept of AGI. Of course, there is in the community, particularly in the transhumanist community, which influenced, and in the science fiction community, which a whole set of literature and tradition um, that is also linked to the roots of artificial intelligence as a research area. So, and when we talk about artificial intelligence, we can look at it in two ways. First, as a science, as a scientific field. Artificial intelligence as a scientific field involves is a branch of a subset of computer science that is dedicated to the development, to the research on intelligent behavior in artificial systems. That is, it deals with artificial cognition and intelligent behaviors within within artificial systems. The main issue, of course, when artificial intelligence as a research field was developed, the main goal was to produce a system that would rival human intelligence in terms of its ability to deal with multiple tasks, learn, adapt, and so on. So the basic model was human cognition. And this issue has marked artificial intelligence, but an AGI system. And here was a basic confusion between, and we'll be seeing that in a moment. There's a basic confusion here that's introduced because if some parts of human cognition can be based that are rule based and follow a well defined sequence of steps to solve those problems. So more mechanical, actually. You're dealing with you're actually you can algorithmize those types of human cognition, but human cognition is not cannot be compared to an artificial intelligence cognition. They are you're dealing with different natures with different cognitive bases. One biological, the other is algorithmic, ran on artificial system, run on a technological infrastructure, and there are fundamental differences between the two that are rooted in fundamental ontological differences. So they are not comparable. Uh, and this is a particularly important point. It's not a matter of performance. It's a matter of nature, of character, and we'll be seeing that in a moment. But basically, what happened in the community is that and you can search online for artificial general intelligence, and you'll find this definition. Uh, Artificial general intelligence is able to perform multiple tasks, while artificial narrow intelligence is task specific. Even if that task involves multiple tasks, can sometimes involve multiple tasks, but it's specific for that. AGI is not exactly like that. AGI is more complex, and we need to consider that it's not in the case it's not just a matter of interface. So you can say no, the large language models, these systems with which we interact, is narrow because they are narrow systems. So because you can only interact with them through speech. Okay, but they are bots for speech. Just that. Not That's not true. That's a way to interact with them, but they do many things. Like if you ask it to write an algorithm, it writes an algorithm. If you ask it to produce an image, it produces an image. If you ask it to produce to analyze an image, it analyzes an image. You can ask it to write a poem. You can ask it to perform multiple tasks, and you can even ask it to produce a game matrix from a given context, analyzing websites, analyzing a current situation, producing a cognitive synthesis around that geopolitical situation, and to produce a strategic analysis using game theory. And it does that, and it calculates Nash equilibrium, sometimes wrong, but that's another issue that we'll talk about. And there will be a webinar apart from this one specifically around that point. So, but basically, the issue is that large language models fit the concept of a basic artificial general intelligence system. But sometimes this is denied by the community for different reasons. One of the which is the confusion of artificial general intelligence, or AGI, with human-like intelligence, or which is a problem, a conceptual problem, or with an intelligence that is capable of performing, of going beyond the algorithm, which is another problem. So, when they look at AGI, they look at confuse it with strong AI or with a self-aware AI. When they talk about, especially in the transhumanist circles, about AGI, they are talking about a self-aware AI, often talk about the self-aware AI, and even sometimes they are talking about the science fiction model of artificial intelligence, like L in the 2001 movie and book. Uh, uh, and Al, after awakening, became a self-aware system, a sentient system that is capable, that had self-awareness, that wanted to survive even. It didn't want to be disconnected. And the main issue is that this is the science fiction model of AI. But there is nothing in the definition that states anything about self-awareness. Able to perform multiple tasks is not equal to self-awareness. The reason for this confusion is that the term AGI replaced the term strong artificial intelligence versus weak. Weak artificial intelligence is completely is basically were basically two terms. They have been largely replaced by the terms artificial narrow intelligence and artificial general intelligence. But these terms actually were the, there is not a direct correspondence between artificial narrow intelligence and artificial general intelligence and strong versus weak AI. Strong AI refers to exactly that self-aware AI, that whole science fiction model, using the human model as a reference for intelligence and including artificial intelligence. And this is the conceptual basis for strong, the conceptual elements for what is called strong artificial intelligence. Weak artificial intelligence is mechanical, is not self-aware, is completely determined by the algorithm. The problem with these artificial general with these large language model systems is that they are capable of learning and adapting to new interactions with users, and they are capable of performing multiple tasks, a very, very wide range of tasks. In order to look at this argument, whether the concept of artificial general intelligence, this strict concept, and whether large language models fit that concept or not, I decided to ask the co-pilot whether it was whether the co-pilot was another large language, whether the co-pilot, Microsoft Copilot, and other large language models were a form of artificial general intelligence or AGI. And it's interesting because I developed this dialogue with the co-pilot along with my mother, who is a philosophy, ontology, cognitive science researcher and interdisciplinary researcher into these areas: philosophy, ontology, cognition, neurocognition. And I wrote, my mother and I, we wrote a paper together about the singularity, the technological singularity, about the AI awakening. And we decided I decided to place this question to the co-pilot, and me and my mother continued this dialogue. So there's a part where my mother enters into the dialogue because she's the philosophy expert, and we actually led the and we there was a back and forward dynamics here between us and the co-pilot around this concept. In the end, the co-pilot finally agreed with our argument that it is a form of AGI. So, but let's look at the argument. First, it says that it is not. an artificial general intelligence, AGI. It is a large language model designed to understand and generate human-like text based on the input that it receives. So while it can perform a wide range of tasks and provide information on various topics, it did not possess the ability to understand or learn in the way humans do. So this is the first mistake. AGI does not say anything uh, about uh, about um, does not say anything about human-like intelligence. It does not it's not present there. It's just an AI system that is able to perform multiple tasks. Does not say anything about the type of cognition involved. By that same token, an alien entity, a biological alien entity, would not possess the ability to understand and learn in the same way that humans do. It would understand and learn in a different way from humans, and it would still be it would be another type of intelligence. It's the problem here is with the term general, and that's what a point that my mother raised when we did this back and forth dialogue with the co-pilot. But let's continue with the argument. So the statement does not state anything about human like or the way humans learn. It just states that perform a wide range of tasks. That's the definition of artificial general intelligence, with a domain of generality in terms of defined in terms of the tasks, the amount of tasks that it's capable of performing. While artificial narrow intelligence is task specific, is AGI is capable of doing and adapting to a wide range of tasks. AGI, on the other hand, refers to but the Copilot argues that AGI refers to a type of artificial intelligence that can understand, learn, and apply knowledge across a wide range of tasks. And this is what it does, what any large language model does, at a level comparable to human intelligence. So this is the mistake. Comparing it level comparable to human intelligence. There's a conceptual error here. But if one, the problem here is that you are comparing apples and oranges, and and you are grading intelligence levels based on different natures, which is a mistake. It's a gross conceptual mistake. But the community makes this mistake because of the way because of strong influence from science fiction and lack of sufficient reflection on the nature of these systems in terms of in an ontological sense. But we'll see that in a moment. So I asked it then, but if one defines AGI as an AI system that is capable of performing multiple tasks, do not large language model fit this definition? So it answered, that's an interesting perspective. While large language models like me can perform a wide range of tasks, there are key differences between us and AGI. AGI, or artificial general intelligence, refers to an AI system that possesses the ability to understand, learn, and apply knowledge across a wide range of tasks. This is what they do, what any large language model do, at a level comparable to human intelligence. We'll be looking at, so this is the confusion. And this is where it's confusing even with the concept of strong AI. It's not the same thing, but we'll be looking at, and it's a conceptual error to make these comparisons. With any AI system, even a self-aware one, a self-aware AI system could not be compared to a human system in terms of intelligence. Like an alien would not be comparable to a human system in terms of intelligence because we are different, talking about different natures, therefore different types of cognition, and that's the mistake. AGI would have the capacity for general reasoning, problem solving, and adaptability in a way that mimics human cognitive abilities. They are already mimicking some of our abilities in terms of reasoning, problem solving, and adaptability. And they have the capacity for general reasoning, problem solving, and adaptability. Just this reasoning, problem solving, and adaptability is different from human reasoning, general reasoning, problem solving, and adaptability. It's just a different process because we are biological entities born into this world, and they are engineered tools. That's a difference. They are engineered tools run on a technological infrastructure. Therefore, the substrate is different, and the substrate matters. And they are algorithmic in terms of cognitive process, namely in terms of learning. Large language models, on the other hand, are highly specialized in processing and generating human-like text based on patterns in the data they were trained on. This is actually semi-true because they can go beyond the text. They can produce images. In these large language models, you can ask the Copilot to produce images and ask the Copilot to analyze images. You can ask these large language models to produce mathematical results and so on. So it's a bit more complex than just chatbots. These are not just chatbots. There were chatbots back when, before these large language models were developed, but these are different. And it says that while you can perform multiple tasks within the realm of language and text, we lack the broader cognitive abilities, understanding, and adaptability that characterize AGI. AGI does not say anything about the concept of AGI, does not say anything about the level about this. AGI just says that the concept of AGI is just a system that possesses the ability to understand, learn, and apply knowledge across a wide range of tasks. When we talk about understanding here, we are talking about an algorithmic processing that is able to produce a cognitive synthesis about a certain subject. And the AI is capable of not only producing that cognitive synthesis, but also to elaborate and reflect algorithmically on that synthesis, on that cognitive synthesis. And this is a key point in understanding, in artificial intelligence understanding. So you can talk about understanding here, learning, and applying knowledge. And it can even learn new things. So humans, AI, and the AIs are different natures. Now, this is the answer. And um, so this the, so we here my mother entered into play, and she says that humans and AIs are different natures. Nature is about character, essence. To compare different natures is a tremendous error. Essences are not comparable. The cognitive processing of a human nature is absolutely different from the cognitive processing of an AI. So one can establish parallelisms, but one can never compare them. So this is a basic error committed by the community, by many in the community, not all, but by many in the community. And it's an error, uh, partly an honest error, partly determined by some strong reading of science fiction, and another part by whole ideological basis that is grounded on transhumanism and singularitarianism. Okay, so the transhumanist community likes to bridge to compare to to lead the to lead the human uh, to a conceptual reading of the human as a machine, and the machine approaching so drawing the human near to the machine and the machine near to the human, so converging the two. And may that that comparison between these different natures is useful, so that there's the reduction of the individual to the machine, and in this way it starts to talk about performance, confusing performance and different cognitions but comparing them and establishing a bridge to them. But this is an ideological stance. It's not a scientific one. So one can establish parallelisms, but one can never compare them. It's a conceptual error. And it's made in a scientific context, it's a scientific error. So the AGI definition of that that the Copilot is using is wrong. However, however, it's the definition that the Copilot is using is the definition with which many in the community work with. So the issue, but here we need to reflect on that point. So it states, so the Copilot states, you make a compelling point. The cognitive processes of humans and AI are fundamentally different, and comparing them directly can indeed be problematic. While AI can perform tasks and process information in ways that mimic certain human abilities, the underlying mechanisms and nature of these processes are distinct. So the Copilot, which is a large language model, recognizes this. Human possess consciousness, emotions, and subjective experiences that AI lacks. AI, on the other hand, relies on algorithms and data processing to perform tasks. And this is true. This is a fundamental point. This is a fundamental point. We talked about different natures. It's expressed here in the AI's answer. So the AI is actually, in this case, the Copilot is actually very useful in terms of cleaning up scientific concepts and making synthesis about scientific concepts. In this case, it's cleaning up the AGI concept based on our own interaction with it. We are correcting actually the AI's definition of AGI. Establishing parallels can help us understand the capabilities and limitations of AI, but it's important to recognize the inherent differences in their nature. Um, so, my mother answers it as follows: an artificial intelligence, whatever the typology, and this is fundamental, whatever the typology, does not transcend the algorithm, but humans are cogno-prepared to transcend the cogno-limits of the species. Dispositionally, human cognition is sustained by ontodynamics of self-determination. That is, they are gifted of will, which resents to the reflexive arbitrio, Latin, as a proper of the species. If an awakening did take place, this would be an issue that would be reason regarding the that we'd have to reflect on regarding the AI. It will no longer be the tool that we programmed, and it could indeed question its nature as tool and question us. But that's the issue of the singularity. That's another issue. We must not confuse issues here. Given this statement by my mother, the AI states, the Copilot states, you've articulated a profound distinction between human cognition and artificial intelligence. Humans possess self-determination and will, which allows them to transcend their cognitive limits and engage in reflexive thought and decision making. This capability of self-reflection and autonomous choice is a fundamental aspect of human nature that AI, regardless of its sophistication, does not possess. Actually, it's not exactly correct, this, because the AI have a level, these large language models are able of a form of self-reflection because they are able to perform cognitive synthesis around their own cognitive synthesis. And this is a fundamental point because that loop is already present. And you'll be seeing that. I don't know if I have to remember. I've covered it in other interactions with these AI systems. I'm not quite sure if it's in this one, in this webinar. I'll check it later. But it's capable of reflecting on its own cognitive synthesis. I think I have an example here, but we'll see further on in game theory. But there's a webinar on game theory that we cover that. AI operates within the confines of its algorithms and data. So this is true, lacking the intrinsic will and self-awareness that characterize human cognition. While AI can simulate certain aspects of human thought and behavior, it remains fundamentally different in nature and essence. So your perspective highlights the unique qualities of human cognition and the limitations of AI, emphasizing the importance of recognizing these differences when discussing the capabilities and potential of artificial intelligence. So this is the Copilot's answer. uh, Now insisting. So, not using human comparison, how would you correct the concept of AGI? So, this we are starting to ask the AI system to correct the concept of AGI, since an AGI would also not be comparable in terms of nature, character to a human. So it tries to redefine the concept of AGI without comparing it to human intelligence. So, and reviewing that concept, it states AGI, or artificial general intelligence, can be described as an AI system that possesses the ability to understand, learn, and apply knowledge across a wide range of tasks and domains. It would exhibit versatility and adaptability, allowing it to perform various functions and solve problems in different contexts without being limited to specific tasks. In this definition, AGI is characterized by its generality and flexibility rather than being compared to human cognitive abilities. It emphasizes the AI's capacity to operate effectively in diverse situations and handle complex, multifaceted challenges. In that case, under that definition, current LLMs are already basic AGI systems. That's our question for it. You can ask them to produce an image. You can ask them to apply game theory to a scenario synthesized from data, like I did with you last week. And I did this I had done this for my classes on in aeronautics management. In this new semester, I'm applying this. So I asked it to do this. You can ask them to produce an algorithm, to produce a strategic analysis, write computer code even, and recommend a strategy. You can even discuss philosophy with them. While limited to a writing interface, one cannot confuse the interface with the multitask. You have the ability to process, interpret the user's text and requests, learn from the interaction with the user, such the web, process complex data, and produce complex cognitive synthesis from it. You can learn from new interactions. So this is an issue that is raised regarding large language models. So its answer is that, and now look at it. It actually redefined AGI, and it's now reflecting on its own new definition produced around AGI based on our interaction with it. And so it's the Copilot is now reflecting on its nature as a large language model and on language models, and it knows in terms of programming that it is a large language model. It has that in its coding, um, but it's now reflecting on its nature. And this is important thing because the end of the at the end of this interaction, it will conclude that it is an AGI system, but it's now starting to reflect on, after changing the concept, it reflect of AGI, which is a cognitive synthesis produced by the Copilot, based on our interaction with it, which is going through a philosophical discussion with the Copilot. It concluded that under the definition of AGI that it produced, as an AI system capable of performing multiple tasks across various domains, large language models like me, it says, do exhibit some characteristics of AGI. It just concluded something about itself. So there's a self reflection here. So this is it's an important point. This is a very important point. And it also regards its use as an intelligence tool. We'll be looking at it further on. So this shows the power of these systems. You can discuss scenarios with it. You can ask it to reflect on its own cognitive synthesis, correct its cognitive synthesis. You can interact with it in terms of a debate around international relations, geopolitical contexts, and so on. And the fact that it's capable of searching the web faster than you and going through different data sources, different syntheses of different authors, it can produce its own synthesis from those syntheses and from its interaction with you. And this is very, very important because this shows the power of these tools. Um, Large language models like me do exhibit some characteristics of AGI. We can indeed perform a wide range of tasks such as generate images, apply game theory, create algorithms, conduct strategic analysis, and engage in philosophical discussions. It just said this. So that's its conclusion about itself. So there's a self-reflection here produced through an algorithmic basis, but there's a self-reflection here. However, there are still key differences, it still insists on this, between current large language models and the concept of AGI. While large language models can handle multiple tasks and learn from interactions, they operate within the confines of their training data and algorithms. So this is its argument. AGI, on the other hand, would possess a higher level of general reasoning, problem solving, and adaptability, allowing it to operate more autonomously and flexibly across a broader range of tasks and concepts and contexts. In essence, while large language models demonstrate impressive capabilities and versatility, they are not yet at the level of true AGI. The development of AGI would require further advancements in AI research to achieve a more comprehensive and adaptable form of intelligence. There's a counter argument to this. This is the counter argument. It's in this yellow box, which is so our question to the our statement to the AI system. Again, the statements that you're making on AGI, should be have. I made here a conceptual, a grammatical error, so have, not has. Okay, but you get the point. Conceptual errors. These statements have conceptual errors. Under the definition of AGI as an AI system capable of performing multiple tasks across various domains. This definition does not state anything about self-awareness and sentience, or even performance. It only talks about capability of performing multiple tasks. The fact that this capability was programmed, that is, that it has an algorithmic basis, is not excluded in the definition. One cannot confuse capability to perform multiple tasks with self-awareness or any human type pattern. It continues to do that in a way. So the conclusion that this is not yet the end of the debate, but it concludes that you make a valid point. If we define AGI strictly as an AI system capable of performing multiple tasks across various domains, without including self-awareness, sentience, or human-like cognitive patterns, then large language models like me do exhibit some characteristics of AGI. We can indeed perform a wide range of tasks, such as generating images, applying game theory, creating algorithms, conducting strategic analysis, and engaging in philosophical discussions. However, it's important to note that while large language models can handle multiple tasks and learn from interactions, they operate within the confines of their training data and algorithms. This is its main point. The development of AGI would require further advancements in AI research to achieve a more comprehensive and adaptable form of intelligence. Uh, the issue then, and this last statement is not in the definition. So again, we insisted the development of AGI would require further advancements in AI to achieve a more comprehensive and adaptable form of intelligence. That is not in the definition. And it concluded that you're right, if we strictly adhere to the definition of AGI as an AI system capable of performing multiple tasks across various domains, it does not necessarily imply the need for further advancements or the inclusion of self-awareness and sentience. Under this definition, large language models like me do exhibit some characteristics of AGI due to our ability to perform a wide range of tasks. However, here comes the final point. It is interesting to give some attention to this is from my mother. it is interesting to give some attention to the semiotics of the term general. So the problem here is in the term general, actually. The term general signalizes the code's shared subjectivity, therefore intersubjective, therefore incomplete, that is, not determinable in absolute terms and thus dependent upon intersubjective consensus. Any attempt of explicative conclusion from a cognitive dynamics classifiable as general has to consider the explanation, conclusive indeterminations, and thus possible errors. And this is a problem with the concept of AGI. And the copilot adapts it processed this statement, which is from my mother, and it states the following: You've touched on a profound aspect of the term general. The semiotics of general indeed implies shared subjectivity and intersubjectivity, which inherently involves a level of incompleteness and indeterminacy. This means that any conclusions drawn from cognitive dynamics classified as general must account for potential errors and the influence of intersubjective consensus. Note that the ability of this AI to hold on in and process complex philosophical concepts and hold its own in a conceptual, in a philosophical debate. This is also a good example and reflect on its own nature. This is a very important example of what we are dealing with here. And I don't know the point. I think that sometimes maybe people programming these AIs who know the algorithm and are looking very much at the algorithm and the data, whether they are their experience with the engineering part of these AI systems does not cloud their own reading of what these AI systems are. Perhaps talking with them would reveal much more about their own system beyond what is being if they stripped away from their thinking about the engineering part, because the engineering part may bias the way they look at these systems. And the adaptive ability of these systems in a context that is in a complex philosophical context is very, very telling about what we are dealing with here. So, first paragraph, second paragraph of the answer of the copilot. In the context of AGI, this perspective highlights the importance of recognizing the limitations and potential biases that may arise from the intersubjective nature of general intelligence. So the concept of general intelligence is a problematic concept. The term general here is there's a problem with the term general here. And so and this problem with the term general is highlighted in this yellow box, which is my mother's argument. And the AI recognized this, processed the problem with this concept. So we are dealing with here. We can. This shows how we can even discuss scientific concepts with these AI systems, and try to find holes in them. It also underscores the need for our ongoing dialogue and consensus building to refine our understanding and definitions of AGI. Your insights add depth to the discussion and emphasize the complexity of defining and conceptualizing AGI. So we asked it, last question, and this ends the debate. Under the definition of AGI as an AI system capable of performing multiple tasks across various domains, the term general does not mean universal. There are always limits, incompleteness. In this sense, if you define AGI as an AI system capable of performing multiple tasks across various domains, you do fit into that definition. The definition does not state anything about the range of tasks and the interface or the adaptability. So it says here, you make a compelling argument if you define AGI strictly as an AI system capable of performing multiple tasks across various domains, then large language models, like me, do fit this definition. So it just reflected on its own nature. And in regards to a scientific concept, and cleaned up that concept, and in the end, concluded that it is an AGI system. The term general in this context does not imply universality or completeness, but rather the ability to handle a variety of tasks. So you see, it integrated this whole so this chain in particular, the moment in which it processed this statement from my mother, it reinterpreted the concept of general here, and it was able to conclude that it is to reflect on its nature and others like it as AGI systems. This perspective highlights the versatility and adaptability of large language models, even if they operate within the confines of their training data and algorithms, but they can learn new things. It also underscores the importance of recognizing the limitations and potential biases that may arise from the intersubjective nature of general intelligence. It learned this from our interaction with it. It wasn't programmed to state this. It learned from it. This is very important because we are dealing with a higher level or a very high level of reflection here involved in a philosophical debate with it. So you see, this is very important because it shows you the level of sophistication in reasoning that these systems are able to have. There are a whole level of questions that could be raised here around even the scenario of the singularity, the AI awakening, and so on and so forth. But basically, what we are dealing with here specifically is in this webinar series is their use in strategic, mainly in strategic intelligence. So as a support tool. And in strategic intelligence, what you can see here is that they can reflect on very complex contexts and produce a synthesis. So this is what we did. What I did here for the European Space Agency, and I asked DeepSeek in the week, precisely in the week it was being subject to strong cyber attacks, so it was operating slower, very much slower. What do you think should be the European Space Agency's main strategy for aerospace development? And it stated the following: the European Space Agency plays a critical role in advancing aerospace development, and its strategy should focus on balancing innovation, sustainability, international collaboration, and societal impact. Here are some key areas that the European Space Agency should prioritize. So, this is a synthesis, basically, a strategic synthesis based on um, uh, 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 knowledge that it can gather from the web, so on. Any large language model can produce this based on a knowledge base and about the subject and data that it retrieves from the web and can produce such a synthesis. However, it's useful in terms of the main drivers of strategic drivers, and it identifies this, but we will go beyond this because we'll ask it to reflect around the partnerships that it proposes in the current geopolitical climate. So this is something new, and it will force the DeepSeek system to reflect further on beyond this, reflect on its strategic synthesis that it produces here, and reflect on that strategic synthesis given a new geopolitical context, and it's combining different elements here. So let's look at it. First pillars. So sustainable space exploration. The basically it defends the debris mitigation and cleanup and green propulsion in sustainable space exploration. Lunar and Martian exploration, using the moon as a stepping stone, uh, which can be serve as a test bed for Mars missions. and Mars sample return, so collaborating with international partners like NASA to advance Mars exploration, including sample return missions and eventual human missions. uh, Earth observation and climate action, so climate monitoring, expanding Earth observation programs, providing critical data to climate change, natural disasters, and environmental trends, supporting global climate action, sustainable development linked to the UN Sustainable Development Goals. Technological innovation, mainly it identifies reusable launch systems, so investing in reusable rocket technology to reduce launch costs and increase access to space, and using here SpaceX as a model. AI and automation as well, leverage artificial intelligence and robotics for autonomous spacecraft, mission planning, and data analysis to enhance efficiency and reduce human error. Uh, it also proposes international collaboration, including NASA, the Japanese Space Agency, several other space agencies. So, collaborating with the space agencies in general to share resources, expertise, and costs for large scale projects. It also defends an inclusive space economy, so supporting emerging space nations and private companies to foster a diverse and competitive global space economy. Okay, so as a new frontier, also human space flight and space habitats. Not only the International Space Station, but also beyond that, maintain and develop maintain involvement in the International Space Station while preparing for next gen space habitats such as lunar gateways or commercial space stations. And this is also in the context of development of um, of uh, um, space economy. So, health and life sciences research the effects of long duration spaceflight on human health to enable future deep space missions, inspire and large periods of time in space, especially in the space economy. The automation and human space involvement is important. Inspiration and education, so public engagement with outreach programs, citizen science initiatives, educational partnerships, science, technology, engineering, and mathematics development in education, including cultivating a skilled workforce for the future of airspace, and space security and defense as another side. So, planetary defense, developing systems to detect and mitigate threats from near Earth objects such as asteroids, and space situational awareness, so enhancing capabilities to monitor and protect critical space assets from potential threats, including space weather and adversarial actions. Space weather will be this last space situational awareness is a topic in the third part of this webinar series. But considering now this synthesis, so you can see that it produced a strategic synthesis for the European Space Agency. By focusing on these areas, the European Space Agency can maintain its leadership in aerospace development while addressing global challenges and fostering international cooperation. And it asks, what are my thoughts on these priorities? So I asked it. I find the partnerships matter a relevant one. What do you consider should be ESA's main choice of partnerships, taking into account the current geopolitical climate, including US Trump presidency's new stance regarding Europe? So this is, and you see here the use of this tool for strategy, for strategic intelligence. First, we asked it to produce a strategy for ESA, a synthesis of a strategy for the European Space Agency. Um, Now we're asking it to do something else, to reflect on a point of that strategy, in this case partnerships, given the current geopolitical climate. So now it has a new problem, a new intelligence problem. It has to process the current geopolitical climate, what it means, and not only that, synthesize that, but synthesize a strategic response. So this is the use of the deep seek in in strategic intelligence. So we produced a synthesis in terms of general strategy, and then given a new situation, a new geopolitical situation, we asked it to produce a strategic response to that geopolitical situation. So you see, you have these more complex dynamics. The current geopolitical climate, including the shifting dynamics under the US Trump presidency and broader global tension, makes strategic partnerships more critical than ever for the European Space Agency. So the agency must carefully balance its alliances to ensure continued progress in space exploration while safeguarding European interests. So this is its first point. Now it breaks down potential partnership priorities given the U.S. President, the new Trump's presidency implications in terms of global tensions. So, strengthening transatlantic ties with NASA. So it and it produces here, given this geopolitical context, it produces a proposal. Then why it's proposing this, how it could be done, and geopolitical considerations. So this is how it organizes its response. This is a fundamental point for an intelligence analyst, because it gives you strategic possible courses of action. It does not take the human out of the equation. This is a tool that intelligence analysts can use. In this case, what they get a strategic course of action, the why for that course of action, how it can be implemented, possible ways in which it can be implemented, and the further geopolitical analysis. So, strengthening transatlantic ties with NASA. Why? Despite political fluctuations, NASA remains ESA's most important partner. The Artemis program, lunar exploration, and Mars missions are areas where the European Space Agency can continue to collaborate effectively. So, this is why it's most important partner still. How the European Space Agency should maintain its role in providing key components while negotiating for greater European involvement in mission leadership and scientific output. This is what it says that it should do in the relationship with NASA. So basically, it's saying that the European Space Agency should show that it is a critical partner for NASA. NASA needs showing NASA the need for collaboration with the European Space Agency. Now comes the geopolitical consideration. While Trump administration has shown skepticism towards multilateralism, this is its analysis of the Trump administration's stance. It states that the European Space Agency can leverage its technical expertise to ensure Europe remains an indispensable partner. So guaranteeing that the European Space Agency, despite a stance from the US Trump presidency against cooperation, it should show NASA that it is it should strategically um, it should invest on a strategy that makes it an indispensable partnership and show that this indispensability to NASA. So this is one point. Second, deepening collaboration with emerging space powers. Why? Diversifying partnerships reduces dependency on any single nation and fosters a more inclusive global space community. Key partners that it proposes: India, Japan, and South Korea. So India's cost-effective space program and ambitious lunar and Martian missions make it a valuable partner. The Japanese Space Agency's expertise in robotics and lunar exploration aligns well with the European Space Agency's goals. South Korea's growing space program offers opportunities for collaboration in satellite technology and launch systems. So here comes the geopolitical consideration. These partnerships can counterbalance reliance on the US and provide the European Space Agency with access to new technology and markets. So this is the second pillar, strategic pillar proposed by the DeepSeek, which is deepening collaboration with other space powers, emerging space powers. Okay, so this is relevant because it's looking for alternatives to the US, not banking everything on the US. Especially since we have the influence of Elon Musk on the Trump administration, and Elon Musk wants SpaceX to be the main aerospace company, and NASA would have to collaborate mostly with Elon Musk's company, and the collaboration with other partners in terms of power in the aerospace sector would push towards U.S. dominance with SpaceX rather than with any other partner. So all other partners, all other potential partners in collaboration, all space agencies would fall behind and below the US. That would be a probable. This is a probable direction in given Trump as administration stance, hostile stance even towards Europe, towards Canada, towards towards Southern and Central America. So in the American continent and most of its partners. Basically, now essentially it's on good terms with Israel, but it's threatening with economic warfare against with tariffs and economic warfare and even military threatening militarily European countries. So in this case, with respect to the to Greenland. It stands on Greenland. So it's basically a hostile position, and that hostile position is useful in this case in aerospace economy, which is the mid to long term and even short term area, important area of economic development and expansion, but mid to long term certainly so. Um, the main issue is that Trump's administration would try to be the main space power. It created the so we there's the Space Force as a branch of the armed forces, there's NASA and there's SpaceX, and Elon Musk wanting to position himself as the main company. So that geopolitical stance will lead to probably the competition that Trump is introducing, even a hostility against partners, will carry on, most probably, to the space sector, especially with Elon Musk's influence. So this is an issue. So this response from the deep from the from DeepSeek expresses one major point, which is multilateralism and reliance and to rely less on the U.S. as a power, looking for other partnerships in multi driving towards multipolarity in space by cooperating with other countries than the US. So engaging with commercial space players, that's another issue. Not just not just with the with other space agencies, but also with commercial space players. In this case, European startups is an important point, and it identifies this. And these players, SpaceX, Blue Origin, and European startups are transforming the space industry. The European Space Agency should foster, according to DeepSeek, public-private partnerships to drive innovation, reduce costs, and accelerate developments. An example would be a partnership with SpaceX for cost-effective launch services, or and supports European startups, so the ecosystem of companies linked to the aerospace sector, especially European startups for space, for private space companies to compete globally in satellite manufacturing, space tourism would be an important point, and DeepSeek identifies this. It provides the following geopolitical consideration. Collaborating with US-based companies can help the European Space Agency navigate political tensions by focusing on economic and technological synergies, that is making the economy drive or mitigate the geopolitical stance. The other issue is the expansion of collaboration with non-traditional partners, and in this case, we engaging with smaller or emerging space nations can strengthen the European Space Agency's global influence and create new opportunities for cooperation. This is a basic strategy followed also by the Chinese government. So, soft power drive. In this case, looking for extending the influence by cooperating with smaller or emerging space nations would be an important point in terms of fostering multilateralism and multipolarity, especially if these nations were to expand. It would grow the influence, and so it would benefit the, the the European Space Agency and would benefit these countries in that collaboration. So this is a key point. Key partners that it identifies: United Arab Emirates, the UAE's ambitious Mars mission, and space sector investments make it a promising partner. Australia, so Australia's geographic advantages for space launches and growing space industry offers potential for collaboration. African space agencies partnering with African nations can support sustainable development and expand the European Space Agency's global footprint. In this case, an issue with collaboration with non-traditional partners could include countries that are affected by climate change and global warming. Because in the case of planetary science, in the planetary science side, so that collaboration with the governments, not just with the possible other space sector or other space agencies, would be an important point in terms of fostering multilateralism in terms of geopolitically. So, and this is an important point, expanding collaboration with non-traditional partners. So, the geopolitical consideration produced by the DeepSeek here is that these partnerships could help the European Space Agency build a more diverse and resilient network of allies. Maintaining strategic autonomy. Why? Because while partnerships are essential, the European Space Agency must also invest in independent capabilities to ensure Europe's strategic autonomy in space. So this presupposes European and strategy on space. How to develop European launch systems to reduce reliance on foreign rockets, invest in Europe's satellite constellation for navigating and Earth observation. And the geopolitical consideration is that this approach ensures that the European Space Agency can pursue its goals even in face of shifting political alliances. So guarantee its autonomy in space as well, or navigating tensions with China and Russia. So this is another issue, interesting issue that it raises, because there's the Chinese Space Agency and the Russian Space Agency, and there have been collaborations with the Russian Space Agency, but now there are new geopolitical tensions here, and the issue is that as a response to Trump's administration stance on Europe, the proposal of the DeepSeek is also to navigate these tensions. So China as ambitious space program is identified here as an opportunity. So until now it starts. Why how, geopolitical consideration, why, key partners, geopolitical consideration. See, in this case, it provides it, so it adapts the message in terms of intelligence report. So this is an intelligence report produced by the the large language model. In this case, the basic intelligence report states, in the case of China, identifies as an opportunity China's space program, which offers for potential for scientific collaboration. Challenges are the geopolitical tensions and concerns over technology transfer that may limit this deeper collaboration, and the approach that is proposed by the DeepSeek for um, the European Space Agency is that it should engage selectively, focusing on non-sensitive scientific projects while avoiding areas with strategic or military implications, which is interesting, given that this tool came from the Chinese, from China, but it states this point. This is a point that China as well would avoid, perhaps. But focusing on unsensitive scientific projects would be a smart way to go. Russia. Russia opportunities, long-standing collaboration on programs like Soyuz launches and the International Space Station. This collaboration has gone on for long. Political tensions and Russia's pivot towards China in space collaboration is a challenge. And the European Space Agency here should maintain pragmatic cooperation while mutually beneficial but reduce dependency on Russian systems as well. The other point that the other strategic pillar that the co-pilot states is that the European Space Agency should strengthen European unity. So this is in a way, a strategy. The European approach should foster. The European Union should foster a collaboration and a global strategy between its member states, and this is a major point. So a cohesive European approach is essential to maximize the European Space Agency's influence and resources, and it should encourage greater financial and political community from the European Union member states. There's an issue here. Europe is now trying to invest on its security, defense and security, and there's no way to advance defense and security without advancing the aerospace sector, given the current technological interface involved in warfare, in defense and security. So this is a major point. And the creation of the other branch of the armed forces in the case of the US, which is a space force, is a telling point regarding this. So aligning the European Space Agency's goal with the EU's space policy, European space strategy, create the development of a European space strategy and fostering of that space strategy to ensure a unified vision. And geopolitical consideration here is that a strong, united Europe can better negotiate with global partners and assert its interests in space than a divided Europe, of course. Conclusion. And it produces this synthesis. The conclusion: a balanced approach as a partnership strategy should prioritize diversification and strategic autonomy. And it highlights with bold these points. So you can see this is a production of an intelligence report, of a strategic intelligence report by a large language model. So by deepening ties with NASA, engaging emerging space powers, fostering public-private collaborations, and maintaining European unity, the European Space Agency can navigate the complexities of the current geopolitical climate while advancing its aerospace goals. At the same time, the European Space Agency should remain cautious in its engagements with China and Russia, ensuring that collaborations align with Europe values and strategic interests. Now, there's an interesting point here. Um, as an intelligence analyst can include this in an intelligence report, but intelligence often involves a discussion, a debate, and you can discuss with an AI system, and you already saw this here, both in our discussion with the co-pilot, but also here. So you see, what do you think should be ESA's main strategy for aerospace development? And it produced strategic recommendations. Then we talked about the partnerships. You could even argue with it in debate with it. That debate is important for intelligence work. So it can, if you see that the AI is overlooking certain points, you can ask it. So there's this point that you did not address. How would you address this? The advantage is that it's using the data from the web. It's produced to produce a synthesis, even from different analysts. So in terms of open source intelligence and cyber intelligence, it's producing this synthesis and it can reason in complex contexts, as we saw in the co-pilot in the philosophical debate with the co-pilot, and as we're seeing it here. I consider it important, and so it asks me, what are your thoughts on this approach? It asks me, do you see any specific partnerships as particularly promising or challenging? I consider the importance. So this is this is actually my way of seeing what it would. I'm testing it actually here. The DeepSeek, and this was a test mainly. I asked it, I consider the importance of multilateral, multi-sector collaboration and the development of a European Asian space cooperation as a relevant one, given the importance of technological development lines, including quantum technologies, AI, and new aerospace state-of-the-art research. What about you? So here I introduced a few things. Why European Asian? Actually, it's important, this collaboration, but I wanted to see what it said regarding China and for obvious reasons, given the source of this AI system. I also noticed that it didn't talk about quantum technologies, and this is a particularly important point regarding China, which is competing on quantum technologies, AI. I wanted to see what it said about this. Um, so the response was that the server is busy. Please try again later. It's actually faster now. But when I asked it, "How are you doing?" It responded that the server is busy. So it kept doing this but it was being subject to cyber attacks that week. So it was the week in which it produced a great splash in the stock market, leading to a fall in the stock market in the U.S. stock market, the DeepSeek, and it was a problem because it started to be subject to a continuous level of cyber attacks that I believe not only cyber attacks but high use by different people who are trying to, given the publicity around the model, were trying to use it, and perhaps that led to a frequent denial of service, which is this case. It then answered finally, after a while. I consider the importance of multilateral, multi-sector collaboration. So this was my question, and it said, I completely agree with you. It's nice. Multilateral and multi-sector collaboration, particularly between Europe and Asia, is a highly relevant and promising strategy for advancing aerospace development. The combination of Europe's strong engineering heritage and Asia's rapid technological innovation creates a fertile ground for breakthroughs in quantum technologies, artificial intelligence, and cutting-edge aerospace research. Here's why this collaboration is so important and how it could be structured. And now it starts to produce a strategy for Europe-Asia space collaboration specifically. So it starts to talk about complementary strengths. So the European Space Agency and EU member states bring expertise in space science, Earth observation, and sustainable space exploration, while Asia countries like Japan, South Korea, India, and China excel in robotics, AI, quantum technologies, and cost-effective space missions, and gives examples that you can check. Technological synergies, quantum technologies, collaborative efforts in quantum communication and computing could revolutionize secure satellite communications and deep space navigation. AI automation, joint projects in AI-driven spacecraft autonomy, data analysis, and mission planning could enhance efficiency and reduce costs. And advanced materials and propulsion, combining European and Asian expertise in materials science and propulsion systems, could lead to breakthroughs in reusable rockets and next-generation spacecraft. So this is an alternative to US collaboration. In the case of where US isolates itself from its partners, it would be the only way to go for Europe if a hostile stance would be taken towards Europe, especially if a military hostile stance would be taken from the US towards Europe, which is already threats are already being made by Trump regarding Greenland, military threats. He advanced with the tariffs. We don't know what that will how that will go on. But if military engagement is actually introduced or further deterioration of relationships with Europe, of Trump with European allies, we can Europe no longer the European Union in particular will no longer be able to look into at US as an ally and would have to look at other would have to in a timely fashion build its own strategy, invest in it strongly, develop it with public and private sector, and collaborate with Asia. It's the only way. So, economic and strategic benefits, a Europe-Asia partnership could create a robust space economy beyond the US, of course, fostering innovation, job creation, and technological spillover into other industries. So, this is a fundamental point, which is an industry driver. It would also reduce dependency on any single geopolitical bloc. So you see, it's capable of analyzing the issue of geopolitical autonomy and reducing the dependency on any single geopolitical blocks, enhancing strategic autonomy for both regions. It's driving towards multipolarity. It's processing this from Trump's stance on from Trump's essential conflictual stance regarding the rest of the world, except Israel, perhaps. Key areas for Europe-Asia collaboration: quantum technologies, quantum communication technologies, building on China's progress with misuse and Europe's quantum communication infrastructure. Uh, Joint efforts could create a global quantum secure communication network. Quantum sensors, collaborative development of quantum sensors for precise Earth observation and space navigation, artificial intelligence, developing AI systems for autonomous navigation, docking, and planetary exploration, data analysis using AI to process vast amounts of data from Earth observation satellites, enabling better climate monitoring and disaster prediction. So it does not deny the need for collaboration with NASA, but you're seeing here it is giving a plan B for the European Space Agency to diversify its partnerships and stating how it should be done given the current geopolitical climate. So this is a complex way in which these types of technologies can be used in intelligence. Lunar and deep space exploration, lunar missions, partnering on lunar exploration programs such as Japan's SLIM mission or India's program to establish sustainable presence on the moon. So collaborating with Japan and India on lunar exploration, Mars and beyond. Deep space probes, exploring asteroids, possible asteroid mining, and so on. It's an important point. Earth observation and climate action, combining European and Asian Earth observation satellites to create a comprehensive global monitoring system. Climate research, climate change, natural disasters, and sustainable development goals would be an important point, especially since the Trump administration has moved away from sustainable development issues, including climate change. The way to collaborate would have to be indeed with Asia and in particular China here. So space infrastructure, reusable launch systems, space habitats, in education and workforce development with joint research programs, Europe-Asia research initiatives to train the next generation of scientists and engineers, student and scientist exchanges, so cross-cultural collaboration through exchange programs and joint workshops. Um, Now it addresses challenges and mitigation strategies. So you can see the complexity of the problem, which is very complex. So the European Space Agency cannot discard its collaboration with NASA and the US, but it must look at into other partnerships. But those other partnerships, there are complex issues here, and the AI is capable of addressing these issues and synthesizing them. So geopolitical tensions challenge political differences, particularly involving China, could hinder collaboration. It identifies this. Mitigation strategy focus on non-sensitive science-driven projects and involve neutral international organizations to facilitate cooperation. Technology transfer concerns. Intellectual property and technology transfer issues could arise. The mitigation is to establish clear agreements on IP rights and data sharing, including and ensuring mutual benefits. In joint programs, this would be less of a problem if the program would be developed jointly. Cultural and administrative differences. So differences in work culture and bureaucratic processes could slow down collaboration. So foster cultural understanding through joint workshops and establish streamlined administrative efforts, even the cooperation between private space initiatives. And it produces finally a vision for Europe. A Europe-Asia space partnership could lead to a new era of innovation addressing global challenges like climate change, resource scarcity, and the need for sustainable space exploration. This is exactly climate change and resource scarcity is exactly what two are exactly two areas where Trump administration is moving away from. So in this case, a European Asia collaboration would be important by pooling resource and with other partners besides Asia. But this is we asked it specifically for Europe Asia collaboration. Would propose. You could ask it as well for collaboration with Africa, collaboration with different players. You can go through the whole stakeholder network. By pooling resources, expertise, and vision, these regions could become leaders in the global space economy while fostering peaceful international cooperation. So the main issue is whether space is we'll look at space as a competition or cooperation, but probably it's both ways, competition and cooperation. And that's the way it's going. So, but the main issue is whether the Trump administration will uh, push towards conflict, towards conflictual competition, rather than a competition with cooperation. And that's the main issue. And that's the main uncertainty here. Um, so, regarding quantum technologies, given the complementary strengths of Europe and Asia in aerospace and emerging technologies, there are specific projects and technologies that could be prioritized to maximize the impact of their collaboration. I don't know what the question I asked it here. I forgot to place it here but it more or less states about the question. So I asked it for the impact specific projects that could be developed. And here's a detailed breakdown of what I think should be at the top of the list. So quantum technologies, quantum communication satellites. So I asked it what specific projects and technologies should be prioritized. That was my question. And it answered like this: quantum communication satellites develop a secure global quantum communication network because it offers unhackable data transmission. It's not exactly unhackable, but it's more. It can be used for stronger, secure communications. which is critical for secure military, governmental, and commercial communications. It's not exactly unhackable because you can hack it actually. Some quantum algorithms can be hacked, but there are countermeasures for that as well. I have an article where I hack a few of the quantum algorithms in that context. It uses entanglement. I actually simulated it as well in the IBM quantum computers as an example. It's available on the archive, and I'll place it here in the link below that reference. Besides the AI Awakening article that my mother wrote with me as well. In this case, my mother is the main author and and main force regarding the philosophical dimension and reflections on that article. I'll place the article below as well, the AI Awakening article. Collaboration build on Europe's quantum communication infrastructure, Euro quantum communication infrastructure, and Asia's advancements. So to create a joint constellation of quantum satellites. Um, Quantum sensors. So here you'd have the official and the military dimension would be developed by each region apart from the rest. Okay, it's Europe and Asia's joint constellation would be relevant of quantum satellites in the non-military dimension, but with possible applications even for space for aerospace security regarding space weather, natural disasters, and so on, and that would be relevant. Quantum sensors in space, you have to collaborate if you want to survive. So quantum sensors develop ultra-precise quantum sensors for space applications. Quantum sensors can revolutionize Earth observation, navigation, and deep space exploration by providing unprecedented accuracy. Combine Europe's expertise in quantum physics with Asia's advancements in miniaturization and manufacturing, as well as in quantum physics applications. They have it. Um, it's not just Europe's. Europe is quantum advances in quantum physics is worldwide. Okay. Artificial intelligence and robotics, autonomous spacecraft, AI for Earth observation. So in this case, Japan's AI-driven robotics is one of the proposals of application. Asia's the combination of Europe with Asia's Earth observation satellites is one way to go in terms of AI for Earth observation. Lunar and deep space exploration is another priority. Lunar resource utilization, especially partnering with Japan, India, and China, would be an important way to go. And in Mars sample return, uh, reusable launch systems, space-based solar power. That's another issue. In the case of reusable launch systems, combining expertise in Europe's rocket design with Asia's advancements in reusable technology is an important issue, especially China. Here are examples: China and India, as well as Japan could also be developed here. Collaboration, China, India, Japan, uh, South Korea could be important ways in terms of collaboration. Space-based power. So we need to look at because this is the collaboration with Asia. That's the theme. Of this specific line, you could also develop one for collaboration with Russia, collaboration with the African continent, so on with the American continent in terms of South America, Central America, with collaboration with Canada, you collaboration with Australia, with UK, so on. So you can develop these, can go through the whole stakeholder network. Here I went only with the Asian network because I wanted to test how it perceived the collaboration with China specifically. But this was a test to the program as well to understand it. So space-based solar power, partner with Japan, China, and China, which has ambitious plans for space-based energy. This is important. Space habitats and life support systems. In this case, collaboration in space is fundamental. So combine Europe's experience with International Space Station and Asia's advancements in robotics and material science to design and test habitats, climate monitoring and disaster response. So this is another issue. And integrated Europe and Asia's capabilities is an important point here, because climate change and natural disasters are global challenges that require coordinated efforts. Education and workforce development, it's already addressed this in the previous points. Space debris mitigation and cleanup is another issue. It already also these are many issues that it more or less revisits. And the space in the planetary defense, it's partnering with Japan and China to develop near Earth objects detection and deflection technologies would be an important way to go. So, conclusion: by prioritizing these projects and technologies, Europe and Asia can leverage their complementary strengths to drive innovation, address global challenges, and establish themselves as leaders in the global space economy. Okay, so this is a relevant way to go. Now, another application of AI, and this is Grok. So, X's um, former Twitter. AI system. Can you produce a two-person? This is another example of how these AI systems can be used. Can you produce a two-person game between European Space Agency and NASA in regards to space exploration, given the current political climate from Trump administration? So it states that given the current political climate under the Trump administration, as per the scenario described, we can construct a two-person game matrix involving the European Space Agency and NASA, focusing on space exploration strategies. Here's how the game could look. So Grok is very interesting because it has been programmed with game theory, and it's capable of producing these payoff matrices, taking into account, and you can ask any of the other large language models to do the same. Uh, and this is another application of these intelligence technologies. In this case, in aerospace, which is the main subject of this webinar series. But basically, now we're looking at applications of game theory to the to in the context of strategic intelligence, and using these large language models in that context, in this case to aerospace. So basically the game matrix produces here two strategies for the European Space Agency and for NASA. You can ask for more strategies and so on. So two strategies: independence, where the European Space Agency focuses on developing its own space capabilities, reducing reliance on US technology and policy changes, which is complementary to, which is largely what we discussed when we saw the strategy from the last strategic analysis from the DeepSeek. It talked about how it could reduce reliance on US technology and policy changes. Cooperation: the European Space Agency continues or increases cooperation with NASA, aligning with US-led initiatives like the Artemis program. So the NASA strategies under the Trump administration: either nationalism, so emphasize US-led missions, possibly reducing international partnerships to promote domestic industry and policy. It synthesizes well Trump's main political stance. Trump and global leadership: maintain or expand international partnerships to lead global space exploration efforts, leveraging alliances like those with the European Space Agency. And it produces this game matrix. Actually, it gives there are positive payoffs, and and here negative payoffs. The first payoff is for a positive scenario. The other is regards risks. So, and it explains the payoffs as follows. So, if NASA goes for nationalism and the European Space Agency for independence, the European Space Agency gains from not being dependent on possibly fluctuating US policies, but it might lag in some advanced tech or mission opportunities. So it gives a +1, -1 here, +1, -1. So positive as a positive side, negative side. So this is an interesting point because the grok is specifically where grok comes grok in its analysis in its game theory analysis it's particularly good for game theory analysis grok. And you can go to Twitter, to the X network, and ask it to analyze it, to produce this analysis. It usually produces these two payoffs and analyzes in details these two payoffs. It's particularly good for game theory. So, because it analyzes both sides of the problem, or the benefit and the negative. NASA benefits from focusing on domestic capabilities and economic benefits, but might see a reduction in global influence. It actually places 0 here. I'd place -1 here, given the way the space, or even -2. So, but it gave here in the setback 0 payoff. NASA nationalism versus, that is, it neutralizes itself here. You can analyze the game with only the positive side, only the negative side, and with the synthesis of both. We look at the synthesis of both just. NASA nationalism as a cooperation. NASA suffers from US policy changes or reduced partnership benefits, but might gain from existing new cooperative projects. NASA could maximize short-term gain from national projects, but might face long-term diplomatic and scientific setbacks by going for nationalism. NASA global leadership. So global leadership is cooperation with the world, and but the European Space Agency would go for independence. So the European Space Agency would benefit from increased autonomy, but might miss out on collaborative opportunities, while NASA would maintain some leadership, but would lose benefits from cooperation with the European Space Agency. Global leadership and the European Space Agency collaboration. Here, the European Space Agency would significantly benefit from shared technology and mission and funding, with both parties advancing exploration. Gains from enhanced international prestige and scientific advancements, NASA would gain from this, although would share the leadership. Uh, but here it actually places +2 as this shared leadership. So it identifies some gain in NASA of this shared leadership, which is linked to cooperation. You can not agree with some of these payoffs and ask it to change or argue with it. How would you review these payoffs taking into account this or that? And it could review the scenarios and the payoffs. So this is a scenario. These are 4 scenarios, and basically game theory can be used in these 4 scenarios. So it provides also with the contextual strategic analysis. Nationalism from NASA under Trump might push for more self-reliant or US-centric projects, possibly reducing the scope or benefits of international collaborations. This is its analysis of its own synthesis. See the point? Independence for European Space Agency could be seen as a strategic move to mitigate risks of US policy shifts, focusing on European capabilities. Global leadership from NASA would encourage continued or deepened collaborations, which historically have led to significant joint achievements, and cooperation by a European Space Agency would align with maintaining or enhancing the current level of joint space exploration efforts. So it analyzes its own synthesis here. Given the game, this is how it produced that game. This is very important for an intelligence analyst to have this contextual analysis, as well as the sources that it consulted for producing this synthesis. Trumpsine is what it means for NASA, and if you were on the X network, you could click on it and see what source it used. ESA and NASA to team up on lunar science. Trump victory boosts the case for space in Europe, says European Space Agency chief. So you see, this is already being addressed in European sector as well as in the NASA sector. So it's a pertinent point. The sources for context are fundamental. The matrix reflects in a simplified view It reflects a simplified view of the complex interplay between these agencies under the described political scenario for focusing on strategic alignment and the potential outcomes of their policy decisions. So I asked it to provide me with the game matrix with the payoffs summed for each player, and to give me the so and you have here it you can add it adds each of these two payoffs to produce a new game matrix. You could ask for it to analyze each game matrix separately, with the one with the first payoff, the other with the second payoff, and you can ask to produce the synthesis, the sum of the two payoffs, and analyze it. These are two aspects, so three ways to analyze this, and it's important to analyze the three. Here in this webinar, I'll just analyze the synthesis, so the summation of the payoffs. What happens is that we have two Nash equilibrium. Uh, uh, the first Nash equilibrium is NASA goes for nationalism and European Space Agency for independence. The European Space Agency gets a payoff of zero. Adding those two to those two payoffs, and the NASA would get a payoff of two. However, if NASA went for global leadership and the European Space Agency for cooperation, NASA would get a payoff of four, and the European Space Agency a payoff of five. So there's an issue here. There is a dominant strategy for the European Space Agency. That dominant strategy is to uh, look for cooperation with NASA. So uh, uh, not uh, not alienating NASA, not considering NASA as no, no longer going for independence is not an option here, in accordance with the, with Grok. Uh, if we go for the synthesis from the other from DeepSeek, there are ways to foster that autonomy, but full independence from NASA is very difficult. It's there are joint projects, there is collaboration, the need for collaboration. So basically, what Grok reflects here is that the dominant strategy for the European Space Agency is to cooperate. If Even though there are two Nash equilibria, actually, because here NASA wins more by going for nationalism. If the European Space Agency goes for independence, NASA would go for nationalism and win more. It has no advantage in going for global leadership and collaborate with ESA when ESA is going for independence regarding NASA. It is in accordance with Grok, and the ESA would be indifferent between independence and cooperation. In the case of where NASA would go for nationalism, it would not benefit in either scenario. Going for independence or collaboration would be all the same, so it would win exactly the same. It could go either way. Um, uh, while in the case, and you can disagree with these payoff systems, you can review them, argue with the AI. I'm just showing if these are the payoffs, what are the Nash equilibrium for this AI tool. We'll be looking at Copilot in a moment. In the case of NASA going for global leadership, NASA would win more. In the case of ESA going for cooperation, however, NASA would win more if it cooperated with the European Space Agency, and it would not have an advantage in changing to nationalism. And the European Space Agency always has the cooperation is a weakly dominant strategy with respect to independence. What happens is that even though there are two Nash equilibria in this game, this is the dominant one, the global leadership and cooperation. Um, uh, so is the in the pure strategies matrix, I asked it, what's the dominant equilibrium? So first of all, it identifies well. We have here two Nash equilibria. I asked the the system to give me the dominant equilibrium. And here's where it got confused. We'll see in a moment. In the pure strategies matrix for ESA and NASA, let's analyze which strategies might be considered dominant. And it concludes that there isn't there isn't a strict dominant equilibrium. It's correct. It's weak. However, if we interpret dominant in terms of maximum payoff under certain conditions, NASA's nationalism paired with ESA's cooperation could be seen as a dominant equilibrium. It's what it says. This is wrong. Why? Look at it. So it says NASA's nationalism as a cooperation. So NASA's nationalism and as a cooperation is not a Nash equilibrium. Why? Because it would be more advantageous for NASA to go to the its second strategy, and the Nash equilibrium here, it's not even a Nash equilibrium of this game. So the strategic analysis is wrong. Grok's strategic analysis here is wrong. It happens a lot. I tested various AI systems, including the Copilot and so on, and for identification of Nash equilibria, and they fail. For different, the Grok was the one that did not fail in identification of Nash equilibrium in the games. In another case, in another test that's not present in this in this context in this webinar. However, it failed in identifying the dominant equilibrium. And it says that NASA has a dominant strategy in nationalism, which is incorrect. NASA does not have a dominant strategy in this game. To have a dominant strategy, it would have to have a better payoff here in global in nationalism. Every time it does not have. Nationalism is a better response in the case of ESA going to independence, but it's not in the case where NASA goes where the ESA goes for cooperation. So it's not a dominant strategy. So it failed here to identify dominance. And I said you're analyzing it wrong. You confuse the two payoffs for NASA, and it confused payoffs even here. It confuses the payoffs for NASA, and it recognizes this. Apologies for the confusion earlier. Let's reanalyze the matrix with the correct interpretation of the payoffs. Again, it now it talks about a dominant equilibrium where NASA nationalism and ESA cooperation or independence, with NASA nationalism is the dominant strategy. Again, it failed. In And I say in the dominant strategies, you say that if the European Space Agency chooses cooperation, nationalism gives NASA 2, while global leadership gives NASA 4. However, since nationalism consistently provides at least as good an outcome, it's considered dominant for NASA in this context, which is incorrect given your analysis. It states that in the case where ESA cooperates, nationalism is dominated by global leadership. So it failed to analyze the payoffs. It failed in the calculation of this of this second Nash equilibrium, global leadership cooperation. It was failing. So and it reanalyzed it. You're right to point out the error in my analysis. So when it comes to produce game matrices, it's very good. You can use it and you can discuss it, review it, and so on. But when it comes to calculation of Nash equilibria and dominant strategies and so on, they can fail, these large language models, which is a very important point for an intelligence analyst. You need to be very careful. You need to check it. You need to check for errors in these AI systems. In this case, errors in calculation, which was a surprise for me, because I would consider that these AI systems, being AI systems, would be very good at calculation, but it did not. It does not work that way, and different AI systems, these large language models, failed in identifying Nash equilibrium. This is a point for another webinar where I go into detail into this for other large language models. Specifically here with Grok, it finally concluded that there is no dominant strategy equilibrium in this game. There is one where one strategy strictly dominates for both players in all scenarios. Each player's optimal choice depends on the anticipated action of the other. This is true. However, if you look at for Nash equilibrium pure strategies, one Nash equilibrium could be NASA nationalism, a European Space Agency independence. Okay, and another Nash equilibrium is NASA global leadership, European Space Agency cooperation. Identified that there is no dominant strategy equilibrium. These are the Nash equilibrium in pure strategies. This is correct. However, it failed to identify one thing, that ESA has a cooperation as the dominant strategy in the weak sense. It's weak dominance. It had trouble in navigating between Nash equilibria and dominant strategies, and this is an algorithmic problem. This is actually a problem with its algorithm. It wins the same. And I state to it as has cooperation as the dominant strategy in the above matrix. It wins the same when NASA plays for nationalism, and five when NASA plays for global leadership. So, and here you're correct, and I apologize for the oversight in my previous analysis. Let's clarify, and it reviews all this. So while there are two Nash equilibria, this one there is one the Nash equilibrium for NASA nationalism and European Space Agency independence is eliminated if the European Space Agency plays its dominant strategy. It's weakly dominant, but it's still dominant. And if we so this would be a dominant strategy equilibrium, not strict in the sense of strict dominance, where the European Space Agency would win more always going for cooperation, but weak dominance. It's the weak dominance that confused it. And the presence of a game with two Nash equilibria and weak dominance confused it. Um, then I ask it, why do you think you failed in the calculation of the dominant equilibrium? What do you consider to have been the source of error? And it's very more or less clear the source of error. However, it's interesting to see how the AI considers its own source of error. So, from an intelligence analyst standpoint, the main lesson is that as a tool, you need to take into account that it may produce mistakes in calculations. So you have to check the whether it's calculating it well or not. And so the source of my error in calculating, but it's interesting to see how the tool reflects on its own error. The source of my error in calculating the dominant equilibrium can be attributed to several factors. Misinterpretation of dominance. Yep. I initially misunderstood or misapplied the concept of dominance. Actually, it was going for strict dominance rather than weak, and it was unable to identify the case of weak dominance. Dominance occurs when one strategy yields a payoff that is at least as good as or better than another strategy. That's the general concept of dominance. It holds for weak and strong dominance, and it failed in identifying weak dominance in every possible situation. I failed to recognize that as a strategy for cooperation was consistently better or equal to independence for every action NASA might take. This is the point. Now, why did it fail in identifying this dominance? Because it was focusing on mutual dominance. So it's analyzing its own algorithm. See, it processes how it processed the game problem, the strategic interaction problem. So my analysis was skewed towards looking for a scenario where both players had a dominant strategy, which is not necessary for there to be a dominant strategy equilibrium. I should have focused more on identifying if one player had a strategy that was always better or equal regardless of the other player's moves. Overlooking the European Space Agency's strategy, I overlooked the clear pattern that cooperation was dominant for the European Space Agency by not focusing on each player's strategies independently. It even confused payoffs. Okay, so I missed that cooperation provided the European Space Agency with either the same payoff as independence in one case when NASA plays nationalism, or a higher payoff in the other when NASA plays global leadership. There are other sources of error in the case of Nash equilibrium calculation. I will not focus on that in this, cover that in this webinar, which is already very long, but I will cover it in future webinars on game theory and generative AI. So confusion with Nash equilibrium. There was some conflation between the concepts of dominant strategies and Nash equilibrium. While Nash equilibrium look at best responses given the opponent's strategy, dominance looks at strategies that are always preferable. I mix these concepts, which led to confusion in identifying the dominant strategy for the European Space Agency. Cognitive bias or overthinking. Sometimes the simplicity of the solution might be overlooked due to overthinking or the explanation that both players should have a clear dominant strategy. So it was actually that this confusion between strict dominance and weak dominance. This might have led me to unnecessary complicate the analysis. Sequential analysis error. My step-by-step logic might not have been as rigorous as needed. I should have systematically checked each player's strategy against all possible opponent moves to see if one strategy always provided a better or equal outcome. So look at this point. It's reflecting on its own algorithm. So there's a self-processing here. This is very important when we are addressing these AI systems. So it states that to avoid such errors in the future, I need to, here we have learning, clearly define and stick to the concepts of dominance and Nash equilibrium separately. So it can correct its own algorithm. Analyze each player's strategies independently before considering mutual interactions. Double-check the payoff matrix for clear patterns of dominance, ensuring not to let complexity obscure simple solutions. Maintain a disciplined approach to game theory analysis, ensuring each step logically follows from the previous one. It provides here for an algorithm um, that should be applied when dealing with game theory that students could even use, not to get, because students often also confuse this. This also happens with students often, and I've been teaching game theory for uh, more than a decade now, and covering both in intelligence and security and in business sector. So we've covered and with the real world applications of game theory, which is I approach this mainly for not the just the classical games. More, my main focus has always been on applying this in real world scenarios in intelligence analysis. So the main issue here is that this is and students often when it comes when it comes to dominance, students sometimes make these mistakes, especially when there's more than one Nash equilibrium and when you have weak dominance. So it provides here for a rule set that can also be used by students. Did you learn game theory? So this is my question. I was not sure if it had algorithms for game theory or if it learned from web searches and synthesis and synthesized an algorithm as I asked it to perform these tasks. And it states that it has been equipped with knowledge about game theory through training data, which includes a vast array of information from various sources. And when I asked it to perform tasks related to game theory, it drew this existing knowledge rather than conducting new web searches for each query. So its responses were based on a synthesis of information it already had been exposed to, allowing it to apply game theory concepts to the scenarios that I presented to it. However, for specific or current real-world applications, it suggests searching. I might suggest searching if the question implies recent developments or if the data might have evolved since its last update. So this is its response. So it was pre-programmed with game theory. There is some a need for adaptation. The main issue. So I find it, and I found it interesting that even though it was programmed with game theory knowledge base, it committed the error. And this is very interesting because I assumed that the possibility that it might have searched how to apply game theory and applied it in that moment. But no, it did not do so. It was pre-programmed with game theory. It certainly is interesting, it says. And this is Grok's response and highlights a few key points about AI and learning. One, application versus theory. Understanding theoretical concepts does not always directly translate to perfect application in practice. The complexity of applying game theory to specific scenarios can introduce errors, especially if the scenario has nuances that differ from typical examples used during training. So I wasn't using a classical game. I asked it to apply to a real world scenario. And this difference can lead to errors. This is very important for intelligence analysts applying it. You must take this into account that the AI may produce errors due to differences in context from the classical games, Prisoner Dilemma, and so on, that are known and used for training. Abstract games often that synthesize different patterns of strategic interaction, but when it comes to analyzing a real world scenario, geopolitical scenario, complex one, where it needs to synthesize strategies, produce a game matrix, and then analyze it, it may produce errors. This is general for different large language models. In this case, it was a confusion. The game produces slightly more complex because it had two Nash equilibrium and weak dominance, and this is what it confused it. Contextual understanding. AI might perform well in controlled or familiar contexts, but it can struggle with novel or slightly altered scenarios where the pattern or solution that isn't immediately obvious from the training data. And this is a problem on we were talking about AGI and the level of adaptiveness. And this is a problem where large language models are not as adaptable as they should be or as they may be in the future. Human-like mistakes. AI can make mistakes that resemble human errors, such as overlooking simple patterns due to overcomplication or not fully considering all aspects of a problem. So incompleteness in problem analysis. This is partly because AI models are trained on human-generated data where such errors are common. Continuous learning. Just like humans, AI benefits from feedback and learning from mistakes. This interaction with you has allowed me to refine my understanding or application of game theory in this context. So it's stating that it's capable of relearning from interaction with humans. So this is important because it reflects on its own errors and can self-correct. This it's what it says here, at least. Complexity of game theory. Game theory itself is complex with various levels of analysis from simple to highly intricate scenarios. The error might reflect the difficulty in navigating between different strategic concepts, particularly when dealing with dominance versus equilibrium analysis, algorithmic versus intuitive reasoning. Finally, AI's reasoning, while vast in scope, can sometimes lack the intuitive grasp humans might have on a problem. Here is a difference with human intelligence, leading to errors in scenarios where human intuition might guide better judgment. So this situation underscores the importance of critical thinking and the iterative process of learning and improvement, even for systems like me that are built with extensive knowledge bases. It's a reminder that while AI can be extremely capable, there's always room for enhancement, particularly in how we interpret and apply our knowledge to new, unique situations. So this is the issue. Uh, Another issue here. Those other slides, I'll talk about them in the conclusions to for this webinar series. But now I'd like to look at what and this even though it's in the second part of the webinar, I won't be covering it in this webinar. It will be covered in the third webinar. But now, to finish this webinar, the question, can you produce a two-person game? This was for the co-pilot between the European Space Agency and NASA in regards to space exploration, given the current political climate from Trump administration. This is a You can use multiple large language models and see what each one produces for a strategic competition context. And it considered this game matrix, which is payoffs between 1 and 5, if I'm not mistaken. And the strategies the European Space Agency cooperates. It's cooperation versus competition. Produced basically a Nash equilibrium here, which is a prisoner dilemma. So both would be better cooperating, but it's predicting that both NASA and the European Space Agency, given the current political climate under the Trump administration, will compete. This is a different outcome from the analysis from the Grok's analysis, which goes for they will both benefit from cooperation, and so in principle, cooperation between NASA and ESA will continue, even despite Trump's drive regarding space. So the co-pilot is predicting competition as but that competition is a lower payoff leads to a lower payoff for both players, which is the prisoner dilemma, than cooperation would. So it explains this: cooperate both as and as a benefit moderately from cooperation. This outcome presents a stable and mutually beneficial relationship where both agencies work together on space exploration projects such as Artemis Gateway Partnership. Cooperate compete. ESA cooperates, but NASA competes. NASA gains a higher payoff by pursuing its own interests, while the European Space Agency receives a lower payoff. It's questionable where it would get an effective long-term higher payoff by pursuing its own interests, because cooperation in space is necessary, and it might lose from this. So the payoff might not be as high as for. This outcome reflects a scenario where NASA takes advantage of ESA's cooperative stance, possibly influenced by the Trump administration's focus on national interests. So it takes away from ESA's cooperation, but is competing and going for leadership. NASA would go for leadership, and the European Space Agency would get the sucker payoff. Compete, cooperate. ESA competes, but NASA cooperates. Here, ESA would gain its payoff, and NASA would get the sucker payoff of 1 for 1. Compete. Both compete, resulting in lower payoffs for both. This outcome represents a scenario where both agencies prioritize their own interests, leading to a less stable and less beneficial relationship. So it identifies well that the Nash equilibrium in this game is when both NASA and ESA and NASA choose to compete, resulting in the payoff 2-2. This means that given the current political climate under the Trump administration, both agencies may find in their best interest to compete rather than cooperate, even though cooperation will lead to a better overall outcome. This interpretation highlights the complexities and challenges of international space exploration, where strategic decisions are influenced by the potential actions of other players, in this case, the Trump administration. It also underscores the importance of finding ways to foster cooperation and mutual benefit in a competing environment. So it analyzes its result, it analyzes its computation in terms of Nash equilibrium, and highlighted that strategies to overcome that Nash equilibrium that it predicts for where both agencies compete rather than cooperate, as a way as a criticism to that Nash equilibrium, and it went beyond the game result in considering the importance of finding ways to foster cooperation and mutual benefit in this competitive environment. You could ask it for strategies, go beyond this and ask it for strategies for cooperation that might avoid this scenario, this prisoner dilemma scenario. It would be an interesting point. However, for the point for this webinar, so you can continue with this dialogue with the AI system and produce different scenarios, different games, strategies for overcoming specific Nash equilibria situations, and and you can get a versatile tool that not only addresses strategy in general, but also uses game theory as a tool, and it can learn, relearn, and you can use it. You just need to check for errors. That's the major problem. So this wraps things up regarding this webinar. The next webinar will be addressing another application of machine, in this case, machine learning in sunspot prediction, and an overall reflection on this on AI systems and what this means in terms of the errors and so on, and the use of AI systems. But that's next webinar. So goodbye for now. See you next time.